Thank you.
Good afternoon and a warm welcome to the second debate, Bridging the Energy Gap. I believe I have to explain a little bit what the word bridging and energy gap means. So I prepared for you a small presentation which takes you a bit out of the context of shipping and brings you to the world, to the society, to the global challenges. Bear with us for a 5-minute recent video from BBC.
Now, last year saw the fastest annual rise in the concentration of carbon dioxide in the Earth's atmosphere. That's according to data collected and analysis from a research station in Hawaii. The study from the UK's Met Office has warned that CO2 at current levels are incompatible with the target of keeping global temperatures below 1.5 degrees. Concentrations of CO2 are now 50% higher than before humans started burning large amounts of fossil fuels. Last year was the hottest on record, with global temperatures 1.6 degrees above pre-industrial levels. Let's speak now to Professor of Earth System Science at Stanford University and also Chair of the Global Carbon Project, Rob Jackson. Mr. Jackson, hello, welcome to the programme. How worried should we be?
Thanks for having me.
How worried should we be? What do those figures mean?
Well, we should be very worried. This is a much larger increase in atmospheric carbon dioxide than we're used to. We're breaching safe temperature levels well past them. And I think the most troubling thing about the increase this year is that it's not caused primarily by a surge in fossil fuel emissions. We estimate fossil fuel emissions are up about 1% last year in 2024. But normally the Earth's lands take up about 1/3 of fossil carbon pollution through tree growth and other things. And the Earth is starting to fight back. The El Nino last year meant thousands of additional fires in the Amazon, record droughts in the Amazon and elsewhere. Plants are not growing as fast, and we're seeing forest death in places. So the Earth is starting to rebel, if you will, and that's deeply troubling.
You say the Earth is fighting back. I mean, the Earth's just going to get on with things, isn't it? It's us that's going to suffer. It's going to correct itself somehow. This figure of 1.6 degrees, I think it's accepted now, isn't it, that we're going to be heading above 2.5. That is the most realistic figure of a temperature rise that we'll be able to attain. Is that the agreed level?
Well, I hope not. Certainly we are heading towards that now. We're not slowing down at 1.5. A couple decades ago, it would have been inconceivable that we would have so casually and cavalierly blown by the 1.5 C threshold where we are now, but we did. And we may do the same for 2.0 and head above 2.5, which is a deeply troubling world with sea level rise, ice melt, and extreme weather. We do not want to go there, but we just seem to be sort of whistling down the street, ignoring what's happening around us.
Okay, so in terms of what is happening, why are we seeing this fastest rate of carbon dioxide entering the Earth's atmosphere? I mean, we've got the COPs, we've got the statements, we've got the increase in renewable energy. Why are we still burning more fossil fuels, and where is this concentrated?
Well, we're burning more fossil fuels in almost all regions of the Earth. Europe is the primary region, really the only region where fossil fuel emissions have actually decreased. So thank you for all of your efforts. But elsewhere, we're burning more. One thing we're doing around the world is producing more and more energy. So we're building wind turbines and solar panels. But because there's so much extra demand for energy, that renewable infrastructure does not mean that we're taking fossil plants like natural gas and in some places coal offline, and we need to take fossil plants offline and replace them with clean energy.
Are we going to do that? Do you think it's attainable? Because it looks as if man's development and what needs to be done to protect the Earth, I mean, they don't correspond at all. I mean, one of the latest concerns is that the growth of AI and the energy needed, of course, to cool those huge sources and the power that's needed to generate and all the processing, the energy that's needed there, where is this energy going to come from? Fossil fuel, isn't it?
To some extent, there's a discussion here in the United States about extending the lifetimes of coal plants that were scheduled to be taken offline in the next few years because of so much extra demand for energy, partly coming from data centers and AI and things like that. We have an insatiable appetite for energy, and that appetite means we need renewables and nuclear, and we're still burning fossil fuels instead of reducing emissions.
Okay. Professor Rob Jackson, I was about to get onto nuclear there, but I've run out of time. Thank you very much indeed. Thank you.
Thank you.
So, CO2 is on the rise. It is supposed to be reduced. At this moment of time, we have the highest number of tankers on order than ever. That includes gas carriers, product carriers, and crude oil carriers. CO2 is on the rise, and the planet is starting to rebel. Everywhere else, other than Europe, more fossil fuel has been consumed in 24 than in 23. That's a matter of fact. This happened very, very recently.
The next item here is the withdrawal from the Paris Climate Treaty.
Donald Trump, first day in office, withdrawal from the Paris Climate Treaty. His comments went on, where he mentioned to the applauding crowd, the US will save $3 trillion by not keeping the Paris Treaty alive. $3 trillion. A little bit of facts and predictions which actually drive the climate change. And again, ladies and gentlemen, this is not shipping. This is global. This is the challenge we have to take if we talk about and mean decarbonization. Look at this. Our beautiful planet has today 8,201,000 inhabitants. In the next 2.5 to 3 decades, we will add another 2 billion people. We add these people in the developing continents, Asia and Africa. When we talk about absolute numbers of emissions, then we have to accept that these additional 2 billion people will at least require an equal life the current inhabitants of planet Earth enjoy. A house, a bit of mobility, education, and food, and IT infrastructure. So we will have to add energy to feed these additional 2 billion people. In this graph here, I depict the energy which was generated through fossil fuels. And when we talk about energy, ladies and gentlemen, don't mix it up with electricity. Energy means transportation, industry, food, and electricity and heating and cooling. Our whole energy which is required to run the world. Until 2023, we were able, through nuclear, hydro, solar and wind, to generate this amount of energy. there is a gap. There is a massive gap between the renewable energies and what we take out of the fossil energy. Now, how do we bridge this gap? How do we actually make this to happen and this to happen? Do we honestly believe that we can multiply by factors of 10 our current wind and solar production when we have a shortage of copper, a shortage of lithium, and a shortage of raw earth materials already now? How are we going to do this? That's the main question which we have to bear in mind when we talk about saving the planet. Sustainability. How can we be sustainable when we have to address these factors? They clearly give the indication we are not sustainable. BBC made it very clear in the interview. All our numbers regarding emissions are beyond comprehension with regard to required reductions. So we need to do massive more things. Please do not ignore this factor. An average person in the world consumes 58 kilowatt hour per day. In India, and Sunil can confirm this, it is only 19. In the US, 219. So we have a much higher energy usage per person in the developed countries in comparison to the developing countries. Now, we have to accept that the developing countries develop. There is an internet. There is mobile phones. There are computers. There is a demand for better housing, for more transportation, for more high-speed trains, for more planes, for more buses within India, within Africa, and within China and Indonesia. So will China and India remain on these low energy consumption per person in the years to come? The answer is no. If we only assume that China and India reach the level of the United States, buckle up, the total energy demand will increase by factor 6. Yeah? And this do not include the new movement towards autonomous driving. Once we start with the autonomous cars, the autonomous drones and buses, we will add data in astronomical numbers. We need data centers which do not exist in order to carry on with that what everybody believes is already the normality. Autonomous cars, autonomous ships, yes, fantastic. But how do we handle all the data? Where do we get the energy to power up the data centers? And that is one reason why actually our CO2 emissions don't really come down, or our fossil fuel usage is not coming down. Because we are adding new demand on a daily basis. And the new demand outstrips what the industry can provide in renewable energies. That is reality. BBC mentioned that they have taken emission data from an institute in Hawaii. It's true. That institute exists. I checked it. And they charted the CO2 which they measure on a daily basis from 1960 to 2024. That is this graph. Don't we agree that there is a steady increase in CO2 emissions in our atmosphere based on this data? This is hard data. This is no gimmicks here. What happened in 2019?
COVID.
Corona. Bravo, Dieter. The world came to a standstill. No crew changes, no driving with the car to the office, no vacation. Home. The emissions went up. Why? Why? It was a time when we experienced the communication tool Skype. And I believe you all remember when we were Skyping through the modem. Can you hear me? Can you hear me? Hello? Do you hear me? I dial again. That was pre-COVID. COVID came. And within very few weeks, all of the sudden, there was technology available. We could have Zoom meetings. I didn't know what Zoom was before COVID. We had Teams, we had all this. Yeah? And the whole world was doing that the whole day. Streaming and using the technology. Beautiful. Shopping stopped. And the home delivery came. Our packages, our cartons, they fly into our house, apartment. The most inefficient way to transport things is to transport it in small parcels. Yeah? The secret of shipping was always economy of scale, put as much as possible into the ship. Yeah? We go the other way around. The paper industry is exploding because the cartonnage, which is needed for all these little packages, required new factories. That's a fact of life. So the emissions are on the rise, and they continue to rise with the additional people we add to the planet and with the way how we entertain our day-to-day life. Here is a graph about the shipping industry. It starts in the year 1837. That was when the first steam vessel made her voyage across the Atlantic. And of course, the vessel was burning coal to run the boiler. And the ton-mile CO2 emissions were the red bar, as you can see, 1484. Very, very inefficient. But the industry continuously became more efficient without IMO, because the IMO only started to be after World War II, 1949. Prior to that, no IMO, but this is what the industry did. Contributed tremendously to the decarbonizing, simply because fuel was expensive. And the ship owners enjoyed technology, or demanded technology, to be introduced in their ships to burn less fuel. The diesel engine came, and then the diesel engines became more and more efficient, and today we are at this extreme low level while we have increased the speed of the ships. The speed from around 8 to 9 knots technically went up to 26 knots. Now we are slow steaming, so we are doing a little bit less. So the industry actually can do a lot of things. But we have reached a level here where significant changes are technically not possible. Yes, we can improve more, but so significant that we can combat the climate change when we are already that efficient is not realistic. So what we have to bear in mind is there's not much time left. We should not fall into the trap of ideologists. How dare you? This is a nice wake-up call, but it is not contributing to the solution. This is the solution. The minister mentioned the collaboration among all stakeholders, and I would like to add to that what the minister said, that we shall not exclude the people. These are, by the way, not seafarers, yeah? These are people working on a short terminal. They are people. We have to take the people on board if we want to decarbonize, because people have to change their life. One more figure, and then we will kickstart the debate. Do you have a rough idea about how much water an average person is using a day? Average person, it's correct what you said, but not for the global average. The global average is 150 liters. In Cyprus, we are at 200 liters. And in India and in China, we are at the figure what you have said. Right. Let's take the average of 200 liters. That means per year, take and give 200 tons of water. Right? Now, how much water do we spend to produce cotton and sew a pair of jeans? One pair of jeans. How much water? Depending how far the cotton is away from the cotton thing, it is a factor between 7,000 to 10,000 liters. That means one pair of jeans, in the worst case, is requiring 10 tons of water. 10 tons of water. And then we cut it. And we wash it, and we wash it, and we throw it away after 3 times. This is reality. This is how we live, and how to bridge this energy gap. That's my question. So we have a fantastic panel in the first session, and an even fantastic panel in the second session. In the first session, we will talk about technologies. What technologies are really available, and how these technologies can be used to enable somehow a better efficiency. The panel will not claim that they will deliver to you how we fix the planet, okay? But the panel will give you some insights of where you still can tune the screws and the machinery to get a little bit better. And in the second panel, we will highlight the real pain points the shipping industry has, and with some practical approaches, you will get an insight of what we should do immediately in order to be a little bit better prepared for the years to come.